Okay, so this video is going to be on data acquisition, cleanup, processing, and a whole slew of other things. So this one might run a little bit long, but this is what a practical data miner will actually do. Sometimes they're called data scientists, data engineer, but there's a whole process to this thing. It's not just taking an R file that somebody else has made for you, putting it in Weka, clicking a couple things. There's a whole process. I'm going to give you a slight glimpse into that process. For the rest of the semester, you're still going to get a lot of hand-holding, but a lot of you are going to kind of go out into the real world and have to deal with this stuff. So I really wanted to give you some hands-on experience and really understand the process. So this is a data mining competition site, and they have a lot of other cool things, so you should probably check it out. I think you can browse all the competitions without logging in. I'm not logged in right now. Kind of the entry level one is the Titanic data set. So this site has a bunch of different data sets, and they're in different formats and of different quality, and some of them get really complicated. You might have to have a physics background to actually understand. You have to do these things called Fourier transforms, and this one's really simple. This one takes all the passengers on the Titanic, and it classifies them as either survived or not survived. They either lived or died through the Titanic accident. And then what you do is they give you a train data set, and you train your model, and you get it to a point that you think it's good, and then they give you a test data set. And so the train data set actually has whether they survived or not, and then that way you can figure out if you've got a good classifier or not, and run some statistics. And then they give you test data. Well, the test data doesn't have an answer. It just has everything but the answer. It has everything but whether they survived or not. And so with these competitions, essentially what you do is you train your model on the train data, and then you run your model on the test data set, and then you have some answers whether they survived or not, and then you upload that to their website, and then they kind of give you a ranking on their leaderboard, how well you did. Some people cheat because the Titanic is a pretty well-known data set. This data set's been out there, so it's pretty easy to cheat. It's kind of outside of the spirit of it, but a lot of people take it serious and really try to train their models as well as possible in an honest fashion and get as high a score as they can. It's really good hands-on training. So I would suggest going out and checking it out if you can. Otherwise, just kind of follow along the video, and you'll still definitely learn a lot just by following along this video. So I'm going to start off with the training data set, which I've downloaded. Don't worry about what these other ones are. Really the only two that you're concerned with are train and eventually test. I don't think I'll actually test anything in this video. I'll just stick to the training for right now. So I've downloaded this training data set, and this data is a little cleaned up already. It's in a CSV. A lot of times you might not even get a CSV, but a CSV just stands for comma separated values, or something to that effect. And you're going to get a text file, and each record, each example, each instance is going to be a row, and then you have a bunch of different features, and those are each going to be a column. And so when I get a CSV, you can see that Excel already wants to open it. The very first thing I do with a CSV is I open it in some sort of text editor. And by far the best text editor that I've worked with is this one called Notepad++, at least on Windows. If I'm in Unix or Linux, I have other ones that I like to use. But this one's a really, really good Windows text editor. It has syntax highlighting. WordPad and Word aren't really that great because they kind of do things in the background that you don't see, but this is great. This just is plain old ASCII text, and it will syntax highlight and do a lot of nice things for you. So if you're interested, go out and download it. It's free. It's a pretty popular program. Everybody I've talked to, I can kind of use it like it's a given, like we're talking about Word or Internet Explorer or something. That's how many people use it. It's really, really common. So I'm going to open with that, and we see we have a bunch of data. Let's go through this data here. Well, I'll show you in an Excel, but what I want you to see for now is that we have on the very first row, a CSV is basically your column identifiers, and then after that we have comma separations for every single one. So the first row, or the first column, is the passenger ID, the second one is whether they survived, the third one is the passenger class, and so you can see it's just comma separated. If there's spaces, you have to put it in quotes, and we'll deal with that in a little bit. If there's a missing value, you can kind of see 2 commas in a row, and that's very common for data, is to have a missing value. So you kind of get the general idea of what's going on here. I'll make sure to post this data in Blackboard and definitely take a look at it either in Notepad or ideally Notepad++. So now I'm going to go ahead and just double click it, open it in Excel, and really any type Excel type program will be able to open up a CSV. So if you prefer OpenOffice and that line of tools, that's fine too. If you're a programmer and you have other ways you'd rather deal with it, that's just fine as well. Okay, so let's start to look at this data. So we're obviously not going to be able to use all this in our model. So we have to go through and decide what we can use, and I'll give you the reasonings why we can and can't use things or not. So this first column is going to be the passenger ID, and so really ask yourself, does the passenger ID actually give us anything in our model? In the competition, you actually do need the passenger ID, so that if you're going to be in the competition, don't touch that. But for our purposes of just kind of evaluating some algorithms, it's not really required. So I'm just going to go ahead and delete this one. We definitely need to know whether they survived or not. So that's going to be our output. And we're actually, Weka tends to like the classifier attribute to be at the end. So in a little bit I'm going to move that to the end, but we'll leave it there for now. This is the passenger class. This will definitely tell us some information about whether the person survived or not, right? Because that's kind of a known thing that the higher the passenger class, they tended to let those people on the life rafts or the boats first, and there's a lot of reasons why that would factor in. So we're definitely going to keep that one. We're gonna even if it weren't useful, it's probably useful enough and it's in a good format that we'll let the model decide if it's useful or not. Now we have this their name. By itself, this name is just going to be a string. So you see how this passenger class, it's either 1, 2, or 3. That's something our models can work with. The models don't tend to work very well with strings, and so I tend to get rid of them. Some models can kind of sort of do things with strings. In general, they really can't. And just kind of from a logical or intuitive sense, if you were doing data mining, what information could you get just from a name? And so typically there's something called feature engineering, and what that means is I take something that's kind of unstructured like a name, and I might say, okay, I'm going to try to give this more meaning, right? And so and people have done that with this data set. You can go out there and look, and so they've done some cool things, and so they might create a new attribute, a new feature that goes through, and they write a script, and then they look for, okay, is this person single? Were they married or not? So they could look as if it says Miss or Mrs., and then they could separate that out, and then you'd get a new feature whether they were single or not. Apparently, there are some doctors on board for the Titanic, so I'm sure the doctors statistically had either a better or worse rate. I don't know which it is, but I'm sure it's different than the general population, so we can let our learner figure that out. So as you can see, there's a lot of information you could get from a string, but just our learners are kind of dumb. They don't know how to figure that stuff out on their own. We would have to actually write some scripts and programs to pull that information out, and that is known as feature engineering, if anyone wants to look that up. So that's definitely a good thing to look at, but we're just going to delete this because we're keeping it simple and we can't do anything with it. That's kind of outside the scope. Male or females definitely is some sort of classification data that we would say that I'm not sure which is going to have a better chance of surviving, but I can probably say that their chances of survival are different, and then we'll let our classifiers figure that out. I would say age is a good indicator as well, and there may be a positive or negative correlation between that. It could be older people survived better because people wanted to help them out and get them onto the boats. It may be that is worse, that it was everyone for themselves and they just kind of left the older people behind. So it's really hard to say, but we just let our classifiers figure these things out. I'm not sure off the top of my head. I think this is how many siblings that they had on board, and I think this is how many, whether they were married or not or something. So you can look these up, but these are just numeric values. So when you have a numeric value like that, you kind of don't know what it is. It's probably not going to hurt it by leaving them in, and then we can do some feature analysis later. Basically, right now we're kind of getting rid of our strings and those sorts of things. The ticket number is another one that can be feature engineered because supposedly there's some meaning behind these numbers, and so some people have gone through this data set and actually made new features based on the ticket. We're going to leave it alone, so I'm gonna delete this. The fare, it may turn out that people who paid more survived better or paid less or whatever reasoning, but this one's pretty easy to analyze. Unfortunately, the cabin number is another string. If we were able to feature engineer this somehow and group these into whether the cabin was on below deck or if it was depending the level, and that's another thing that people have looked at. They've gone through this data set. Unfortunately, it's strings, and so by default, our classifiers can't really do a whole lot with it. So we're going to delete this, and then where they embarked. And so this is kind of in a good format. I know it looks like a string, but it's only three places. It's S, C, and Q, and I don't know what they stand for. You can go ahead and look that up, but it's something we could classify, and that might give us some more information as to whether they're wealthier or not, or the type of person they are, or any of that sort of information. And so statistically, people from different places may have had a better or worse chance of surviving, so we'll leave that alone. So we've got a pretty good reduced data set right now. It's kind of cleaned up, and this is kind of the pre-processing stage. We're cleaning up and getting rid of stuff we don't need. And so what I'm gonna do right now is I'm gonna cut this. I'm gonna paste it at the end, and then I'm going to get rid of this. And the reason I did that is Weka tends to like to have the classification as the very last thing. So our thing we want to classify is whether they survived or not. So there's a bunch of different ways to kind of do this data cleanup. I know a lot of people in here probably have Excel experience, so that's kind of where I started with. That's kind of my baseline. So I'm going to save this. And Excel likes to complain because Excel really doesn't want to save in a CSV, because in a CSV you can't save formulas and all these other things that Excel has the capability of doing. But really, this is just kind of tabular data. This is just a big table, so we don't really care. We're just going to click yes. We're going to save. That's fine. It's going to ask us a million times. Okay. And so now it's been saved. Now we can look at it in Notepad++, and we see our reduced data set. So now we need to do some more processing. And I'll do a whole video on missing values, but right now we just need to kind of get it into a format that Weka likes. And actually, let's go ahead and do a search and replace, and I'll explain what I'm doing here. So I'll type some stuff in. So Weka likes... no, I don't want age. I want 2 commas in a row. Okay, so we're going to do... Okay. So when we have... so Weka expects a question mark. And I don't know how well you'll be able to see that, but... and once I do the replace all, then I'll show you in the data, and it'll make it a little more sense. But what I mean by a missing value is... so this data is like 100 years old, right? And maybe the collection techniques at that time weren't as good, and they had a hard time tracking down families and ticket numbers and all this other stuff. And this is really typical with data, is that you don't have a value for every single piece of data, but you have enough you have enough data that it's valuable for that record, right? So you don't want to just get rid of that data. You want to kind of work around that, and so a lot of these algorithms know how to work around that. And there's a lot of instances where you can't just delete a value, right? This Titanic data, maybe you could, even if, because there were so many people in the Titanic, but a lot of times you can't. If you're looking at patient records and you did some study and you wanted to look at the treatment the effectiveness of some sort of treatment for cancer. Well, you may only have 5 patients who have undergone that treatment. Say it's an experimental treatment and you're doing some data mining on it. And say your equipment could only get so much data, and sometimes the data worked and sometimes it didn't, but you had a lot of different types of data. You don't want to just start dropping patients and records. If you only have 10 patients or 5 patients and you've dropped 2 of them, you've really reduced your effectiveness. So that's what we do with these question marks. So basically I'm saying if there's 2 commas in a row, which essentially means, and I hope that makes sense why that is, if there's 2 commas in a row, it means that the data is missing. The data in between here is missing. So what I'm going to do is I'm going to replace it with a comma and then a question mark, which Weka effectively sees as missing data, and then another comma. So I'm going to do a replace all. And let's see if we can find an instance with a question mark here. So here's an example. So in this case, they didn't know this person's age, and so we just put a question mark. Rather than discarding the whole record just because we don't know their age, we know so many other things about them, and we just don't know their age. So we just kind of have a missing value there. So, and what I'm going to do is I'm going to do a save as, because I don't want to touch the original CSV, and I'm going to actually name this train dot, and we're going to turn this into our ARF file, our ARFF file. So I'm going to click save. Okay. So that's step 1. We got rid of the missing values. So now let's actually kind of put that header, that ARF file header, into our file. So we've talked about this a little bit, that the ARF file format is very similar to CSVs, and typically a lot of other data mining tools you pass in a CSV directly. Weka is a little more particular, so I'm going to start typing some stuff and then I'll explain what it is. So this first thing here, it's our relation. This essentially tells us the name of the data set, and we're just dealing with the Titanic data set. And then now we start to put in our attributes. And so an attribute, as far as Weka is concerned, is either numeric or a classification. So let's look at our first thing here. We've got the passenger class. Well, from what I can tell in this data, even though it looks numeric, and I'm scrolling through here, I only see 3 types of passengers. So I'm gonna make that 1, 2, 3. So that's going to be classification. So now we've got an attribute. And what I'm going to do, I'm just going to copy and paste this. Oh, and I have to give it a name. I should say here. So I've got attribute P class and then 1, 2, or 3. And then I've got their sex, and that one's easy enough. That one is if they're male or female. Their age is going to be numeric. That's just going to be number data. We can't really classify that. That one's just, there's too many ages. Typically, if you've got like under 5 things or under 10 things that you can classify, that's fine. When you start getting into the double digits and higher, you're kind of stuck with numeric. We could probably figure out the range of people that their ages are, and then we could do something with that. But we really want a numeric value on this. And there are other reasons, because as they get older, there may be a better or worse chance of them surviving, and that works well for things like linear regression. If we had a classification, we'd kind of lose that. We'd lose that order. So we'll leave that as numeric. We've got this SIB SP, and let's look at this one. This one also looks numeric. So where are we here? The sex, the age, and then now we're on this one. Let's leave this numeric. This may be classification, but we can do that for now. Same thing with this one. We're just going to leave this numeric. It's not going to hurt anything. We can always go back and fix this later. Then they have their fare, how much they actually paid for their ticket. And that's going to be numeric. Where they embarked. and then that's going to be a classification. So I see S, C, and Q, and I think that's it. I just see S, C, and then Q, and then I can scroll down here, but I think those were the only three places. And then the last thing is whether they survived or not. We can just call that class, or we can let's call it survived. And 0 means they died, and 1 means that they survived. And so now we can actually get rid of this. And then now this is our data. So now we've actually got a cleaned up file. This is we've gone through the process, and we actually took a CSV. We reordered some things. We got rid of some things. We decided which fields were numeric and which were classification. We gave it this little header, and now this is actually a cleaned up file that we can put right into Weka. So I've got Weka up here. I'm going to click the Explorer. I'm going to open a file, and let's say I think I kept it in my downloads and then data. Hold on. There, okay. So now we have our training data. So this is the R file that I just processed, and this is hopefully it works. Okay. This is a tricky process because Weka is really bad about kind of having some flexibility. It wants its CSV files and ARF and everything in a very, very, very specific format. Other programs like Excel are a lot more lenient about what they accept, and they can kind of figure things out. Weka can't figure anything out. If there's one record, one row, one instance that's incorrect, it stops the whole process. It's really not that flexible. So this was an easy data set, especially since I got rid of a lot of the strings, and we were able to do some things with the missing values pretty easily. If it's the first or last missing value, we can't use that technique of replacing the 2 commas in a row with a comma and a question mark and a comma. It gets a little more complex, but we kind of lucked out with this data set. So we got it to work on the first try. So now let's actually kind of play with this, and this is kind of the fun part, because we can start to actually do some things with this data now. We actually have it into a format we can use. And a lot of this pre-processing, and this seems to be a pretty constant thing. Everybody I've talked with says they spend 90% of their time with data acquisition and cleanup, and then the last part, this data analysis turns out to be the smallest part of their time, right? Because you're kind of given data sets, but imagine how much work it is to actually compile a data set, like especially something with the Titanic. That probably took months to actually get that data together. And now, well, somebody's done that for us, and we can just kind of play with these different types of classifiers, and this might be a half an hour of your life, right? This you may use this for an assignment or a data mining competition, but kind of the first parts are what's really time consuming. But what's really the interesting part is the actual stuff in Weka, the classifiers and everything. So I'm going to run a J48 on it with cross validation, and we with the competitions, and I know I've stated this many times, accuracy tends to not be the best measure. Well, with this Titanic data set, because a false positive and false negative, it doesn't really matter. It's kind of just a generalized data set. We're not talking about medical records. We're not talking about real estate. We're not really talking about anything. We're just kind of just looking at this. And so accuracy in this case is probably not a terrible metric. Compared to all the others, it's probably an okay one. Maybe this area under the rock curve would also be another good one. But for the competition, they use accuracy, and that's probably fine because it's kind of a toy data set. You're not really gonna. You're not using it to run your business. You're not going to make any money off of this data. You're not going to use it to diagnose patients. You're not gonna go on a wild goose chase looking for homes that are good deals or not. So when we have even cost data sets, which are, it turns out in the real world, they're kind of rare, but this is the rare case where you have one where a false positive and false negative, there's really no difference because you're just kind of experimenting. So let's so we went through J48. Let's go through another one called the random forest. Random forests are what's known as an ensemble learner, and you'll learn a little bit more about those. So we get some. So we can kind of compare. This one had 81% accuracy with 0.849 area under the curve. This one had 80 and 0.832. So we can see the other one performs slightly better. And from what I understand with this data set, you can't get much better than the low 80s. You might be able to get 83%, 84% if you're really, really good and you've done a bunch of feature engineering. So by default, Weka did a pretty good job. Random forests are known for this data set to work pretty well. There's another one called support vector machines, and I'm not sure what Weka calls those. Let's see if I can find it, because a lot of times there's a standard name and then Weka calls it something slightly different. So let's see if we can find that. Maybe a function. Okay, I think this is it. Whoa. See if I can click it without. No. Let's try to get it quick there. No. There. Okay. Let's see what an SVM does. Oh, okay. It needs external libraries to actually use a support vector machine. So that's fine. We have these. We can play with others. We could do a. I don't think a logistic regression is going to work very well, but let's try it. Worked okay. Didn't work as well as the random forest. The random forest is known to work pretty well in this data set. Okay, so I'm running a little long in this video. I hope that kind of gives you some sense of the process and what actually happens when you look for data and go to download it. I wanted to talk about cross-validation a little bit more. I'll have to do that in another video and kind of splitting your training and test data sets and all that. But check out that website. Start getting used to seeing CSV files out on the internet and acquiring them and doing some kind of interesting stuff with them. I apologize for the video running long, but it's kind of a long process, right? You getting this data and doing everything with it and cleaning it up and deciding what you're going to keep and what you're not going to keep. So stay tuned for some new videos coming up very soon.